So, on your study guide, you have, where my work is. Oh, where was I? Okay. So, number 2, you have that 5 1/4 quarts of, a container holds 5 1/4 quarts of water. How many cups of water can 3 containers hold? So, what answer did you get?
63 cups.
63 cups. So, how did you get that? Astasia, what did you do?
I did 5 1/4 times 3 since there's 3 containers and got 15 3/4. And then since 1 quart equals 4 cups, I did 15 3/4 times 4.
Okay. So, if 1 quart, so we have the quarts, and so you have 15 3/4 times 1 quart. So now we have 3 containers. You see what they did? You have 3 containers. See, I'm going to be going fast, so you can't be spending your whole time writing this down. This should have been done. So, you have, this was times 3. 3 times 5, 3 times 1. You can do a mixed fraction times a whole number. So, 15 3/4 of a quart. Well, I'm doing my conversion because you're trying to figure out how many cups this is. So, 15 3/4 times 1 quart. So, you're changing this from quarts to cups. How many cups are in a quart?
4.
You've got 1, 2, 3, 4 cups in 1 quart. On your gallon man, times 4 cups. 15 3/4 times 4. 15 times 4 is 60. 4 times 3 is 12 fourths. So this, you have your 60, 12 fourths is improper. 12 over 4 is equal to 3. 63 cups. So 63 cups total will fit in 3 containers. So I'm not giving you very long to write this down. If you don't get it, I'm recording it and it's going to be posted because it is 63 containers. Oh, 63 cups. Okay. So now I'm on to number 3. Oops, I went too far in my notebook. Where 7 gallons of peanut butter is used to fill 15 empty jars. If each jar holds the same amount of peanut butter, how many gallons will each jar hold? Express as a fraction and simplify if possible. How much peanut butter would go in each jar? 7/15. You have 7 gallons of peanut butter and you've got 15 jars. I don't even know how many dots I just did, it doesn't matter. So I've got 15 jars. You got the 7 gallons that you're having to split up. Don't write this down. I'm just showing you. You've got 7 gallons and you're having to split this up, divide this up into 15 gallons. So you've got 7 gallons having to go into those 15 containers. 7/15. It really wouldn't make any sense to have this. Because if you did this, then that would be 2 and... Yeah, sorry, I couldn't math it for a second. Would it make sense, would it be a reasonable answer to say that 2 1/7 of a gallon of peanut butter would go in each container?
No.
No. Because if you've got 15 of them, then that would be a total of 30 gallons of peanut butter. If you really truly thought about it, which some of y'all, you write an answer down and you don't think if that answer is reasonable. If you really stop and think about it, this is not a reasonable answer. 2 gallons in 1 jar, that's a lot of peanut butter. If you go to Sam's, you might see it, but that's, or Costco, it's reasonable there. But if you've got that in 15 jars, that's 30 gallons. You started with 7. You see where I'm going with that?
Yeah.
You started with only 7. How can you take 7, split it up 15 times, and have 2 in every single jar? You can't. That's my point. Where if you have to stop and go, is that a reasonable answer? This is more reasonable. It makes more sense. I can take 7/15, split that up 15 times, and if I added all that together, it'd be ugly, but I could do that, add it 15 times, and end up with 7 at the end. It'd be ugly. It'd be a lot of work, but I could take this, multiply it by 15, and at the end of the day, my answer would be 7. Could I take this, multiply it by 15, and get 7?
No.
No, I would get 30 and 15/7. I would not get 7. I would get 7. So it's not a reasonable answer to do this. George has 15 baseball cards. So I want you to think about number 4. You really have to read number 4. You really, really, really have to read number 4. This goes back to early in the quarter. He has 15 baseball cards. He's starting with 15. He gives 6 cards to Johnny. Do you agree with this?
Yes.
All right. He gives 6 cards to Johnny and 3 cards to Chad. So is he giving away 3 more cards? Yeah?
Yes.
So he's giving away 3 again.
Yes.
Do you agree that this is what it would sort of kind of look like?
Yes.
Is there one that looks like this?
No.
No. Do you remember that there was a little rhyme that I made that sounded like something? Do you remember what it sounded like, Ellie? You kind of like this?
I don't remember what it sounds like, but I remember we would add
Subtract, combine in the back. Subtract, combine in the back. Because because doing a 15 minus 6 and then subtracting 3 again is the same thing. If I had like $15, or he had the 15, he gave away 6 and he gave away 3, is the same thing as saying he gave away 9 and take that and subtracting it from 15. It's easier to add those, to combine those, than doing a subtract. It's easier to just add it than doing this. If you've got to subtract, just combine it in the back. Does that remotely sound familiar?
Yes.
Okay, it's been a while though. Because you're not saying that he got any more, but we're just saying that he's subtracting this sum. You take these two together, Nigel, and then I'm subtracting the total that he gave away. He gave all of these away. He gave those away, he gave those away. It's the same thing. Okay, Mandy, all right, so 5 and 6 all come from that line plot. Mandy measured the weight of her purses. The results are in the line plot below. How many purses weighed more than half a pound? How many purses weighed more than half a pound?
5.
How do you know it's 5?
Because you. Yeah. Because you count. And then after 36 and 2 and 6.
Because 3/6 is equal to 1/2. And there are 5 x's on the other side of 3/6. You have to know your equivalent fractions. What was the total weight of all of Mandy's purses? You have to be able to write a number. You have to be able to kind of write a number sentence based on a line plot. When I solve this myself to make it easier, you don't have to do it this way. But for me, I'm saying again, you don't have to do it this way, but for me, when I solved it, I sat at home and I worked out every single problem on the study guide to give myself a key. I did this. What do you think I did with that 1/6? I multiplied it by 4 so that I didn't have to sit there and go 1/6 plus 1/6 plus 1/6 plus 1/6. Why would I want to do that? I can, but why? Take the hood off of your head. So there's 4 x's, so I take 1/6 and I multiply it by 4 because there are 4 x's. And then there's no 2/6, there's no 3/6, and I go to 4/6 plus. What do I do to 4/6?
4/6 times 3.
4/6 times 3. And then no 5/6 plus 6/6 times 2. Now I could do 6/6 plus 6/6, either way. Okay, so 4 times 1/6 would be 4/6 plus 3 times 4/6 is 12/6 plus 6/6 times 2 is 12/6. Okay. So 12/6. Yeah, and this is. I know that this is 2, and I know that this is 2.
That's 4. And then it's just 4.
This is 4, and
4/6.
4/6.
But you have to simplify that.
And you have to simplify. Which, is that an answer? Yes, it is. And I told you, this is not a full take forever, write everything down math lesson. This should have been done. I'm just going over the answers with you. So if you're not getting this stuff written down, you're going to have to go back and pull it up. You have this one done?
Well, I get that.
Okay, do you see where you might have got it wrong? Okay. Okay. On number 7, if there are 8 pans of brownies, there are 43 people, how many brownies could each student get?
5.
I'm sorry, did I read that wrong? 43 students and 8 cans of brownies. How many students could each student? How many brownies could each student get? 5. 5?
No.
8 times 5 is...
Fraction. I know, but it's 43. 43 can't go into 8. Evenly.
Evenly.
Yeah, like you get F6 and then 8 or 3 8s. But you're really gonna split.
Are you really gonna split those little leftovers?
You can do it to 5 and 3 8s. That's what
Well, why?
Me?
6. 8 divided is 43. This is the way I solved it. Now, would you really do anything with those 3 leftovers? No? That's the way I solved it, unless there's another way to do it.
I did. Well, it's not even like
Unless there's another way to do it. There might be, I don't know. But if there is, I will look it up. 43 students share 8 cans of brownies. Here, I just want to move on. Okay. In a room. Where am I? There I am. Okay, I was looking. I turned the page and I shook it. In a room of 49 people. This is a 2-part problem. In a room of 49 people, 4/7 of them are girls. They want to know how many boys are in the room, not how many are girls. They want to know a number, not a fraction, a number of boys. So if you got 21, you were right. So 4/7 are girls, 4/7 of 49. So 28 are girls. 49 minus 28. Is there a lot of times more than one way to solve a problem?
Yes.
Yes. Could you have done 3/7 of 49? Yes. Because if you look at a tape diagram where 4/7 are girls, that leaves the 3/7 that were boys. So you could have done 3/7 of 49 and saved yourself the subtraction step. Same answer, different way. Well, I did it this way too. Yes, sir. But you still got the same answer, right? Either way. Okay. So,
Is that 30? It's 30. Yeah. On number 10.
oh, yeah, I made it 30.
Told you.
But on number 9, Joe spent 3/5 of his money on a new TV. If the TV cost $225, how much money did he have at first? Now this is a magic number problem. You have to do the reverse. Now it got me the first time I did it, and I was like, that's not right. And I scribbled it out and I started over. So if you did it and you got 360, you're wrong.
75.
I said if you did it. Second time I did it, I got 375.
Yes.
So, because using a tape diagram, of course, it was really late when I did this, so you cut me some slack here. So, we have the fifths. 3/5 of the money was spent on a TV. So, and the TV was $225. So then we had to figure out what these 3 units were. So 225 divided by 3. You're having to do it backwards because you're figuring out the magic number. Nigel. Okay, you're writing. Never mind. So this is 721. So each one of these 3 units is 75. So if these 3 are 75, what are those other 2? 75.
Oh yeah, that's what I thought.
Right. So now that I've figured out those 3, I need to figure out the total. How can I figure out the total? Multiplying what?
75
75 times 5. $375. I always move the thing. I keep leaning against my desk and I'm push my mouse.
I survived half the day.
Number 10. There are 30 students in a class. Of the class, 2/5 of the students bring their own lunches. How many students bring their lunches? Well, that one's pretty easy. How many?
12.
12.
What?
You just learned to divide by 5 and 6. Yeah. 12.
2/5 of 30.
I did that, and then that's what I did. Oh, I thought it was
See, I changed the number because it was a number that was not divisible by 5 and you ended up with a fraction of a student. So I changed it. It was like 25 or 27 and I was like, you can't have a fraction of a person. So I changed it. But it's a fraction of a number. And when you have a fraction of a number, you do that. That's one of the easiest ones on here. Okay, number 11, the farmer with the eggs. And this one is one that people miss so many times because you're not paying attention to the dozen, you're not paying attention to the eggs, you're not paying attention to how many he sold. And if you're talking, you're not paying attention to me. No. So, a farmer collected 14 dozen eggs. So we know that he's got 14 dozen. Now we already know, one thing that I started doing is I went ahead, when I got this problem, I went ahead and did one small conversion off to the side. I went ahead and got it done. So, how many eggs are in a dozen?
12.
12. So I went ahead and I said 14 times 12. That's 8. That's 2. 4, 1. So that's 168 eggs. So when he has 14 dozen, that's 168 eggs. That conversion's already completed. That's not, that wasn't even really necessary right then, or possibly was, but I went ahead and did it. So that later on, I didn't have to do it. So, question A, it says he sold 60 eggs at the farmer's market and gave the rest to friends and neighbors. So that's important information. So it says, how many dozens of eggs did the farmer give away? How many eggs did he give away? So we got to do dozens and eggs. So he sold 60 eggs, not sold 60 dozen, sold 60 eggs. So we did have to convert. So for A, that's 168 minus 60. So that's 108 eggs that he had left. What did he do with them?
He gave them away.
Gave away. And I label things when I'm working so I don't forget. So he sold those. He gave away those. I label all kinds of stuff on my work.
And then he divided by 12.
How many eggs did he give away? Right there. How many dozens did he give away? So I've got to say he had 108 that he gave away eggs, and we need to know how many dozen is that?
So you divide.
By what?
12.
12. How many times can 12 go into 108? 9. So it's 9 dozen that he gave away also. So he gave away 108 eggs, which is also equal to 9 dozen. But that's just A. B. He sold each dozen for $3.25. How much did he earn? Well, we only know that he sold 60 eggs. That's not 60 dozen, that's 60 eggs. So we've got to figure out how many dozen he sold. 60 eggs. How many dozen is that?
It's like
5 dozen. Because 60 divided by 12 is 5 dozen. And then if it's $3.25 for 1 dozen, how much is it for 5 dozen? Multiply $3.25 times 5. Two decimals. 1, 2. He made $16.25.
I did not do that at first. If she did 9, I did 9.
Oh, yeah.
My mom was
But that's what he gave away.
Yeah, that's what I said.
Yeah.
That's what I thought you said. So 9 dozens.
I got it. That would
That's what I got. $29.25.
Okay. 3/7 of a number is 24. Magic number. 1, 2, 3, 4, 5, 6. 3/7 is 24. 1, 2, 3 parts equals 24. What do we do with that information?
You divide it.
By this whole thing.
3.
24 divided by 3 is
8.
So each one of these is 8 because all three of those together equals 24.
And then
So if these are 8,
all of them are
the rest of them are 8.
8. And then you multiply times 8 and 7.
So then 1, 2, 3, 4, 5, 6, 7 times 8 is 56. This is not new stuff.
We did that on a test.
Yeah, we did. It was earlier in the quarter. Yeah, we can't review everything every single day.
I like shit.
So, hey Gardner, you want to get a mop today? A gardener has 50 pounds of soil. This should sound familiar. He used 2/3 of the soil in his garden. What do? You do not subtract that part. Multiply 50 by 2/3. 2/3 of the soil.
And 3
So
16 has left a 31.130. That's how much he used.
So he used 33 and 1/3 pounds, but there's another question.
How much do we have left?
2 questions should have 2 answers. How many pounds did he have left? What do you do?
Subtract 50 minus 33 by 30.
50 minus 33 and 1/3. Can you subtract those? Not the way they are.
You have to make 50 into 49 and 3/3.
This is like a whole pizza and you're trying to take a slice out of it and you can't.
But it's not even sliced.
Ryan, are you looking up here at all?
The second question.
Okay. But I was talking to Ryan. So I've got to take one of my pizzas and slice it up because I cannot subtract that. 49 and 3/3. Take one of your pizzas and slice it so that I can take a third out of it. That's from second quarter. You cannot take a fraction. You can't take a slice from a whole pizza. So 49 minus 33, 16. See, if you told me 17, then you did 50 minus 33. 16 and 2/3 pounds.
Yes, I got that. That's not bad. This isn't even hard. I thought it would be simple.
Nope.
But are we allowed to use our conversion?
I'm gonna have to ask the other people. Most of them are on there.
It's the last page.
Okay.
Oh yeah, this is the with like the green paint.
I can't. Okay, so she has the. Sarah has 16 quarts of gray paint. She uses 6/8 of it. 6/8 of it. So that means what?
6/8
Yeah.
8 16.
Uh-huh.
And
So,
do the cross out.
Yeah, cross it out.
And that's 2.
so that leaves her with 2 quarts. And then she uses 1/6 of it for a dresser. Wait a minute, what did I do?
It's 2 times 6 is 12.
Oh my gosh!
Yeah.
You're right, I'm sorry. My brain kind of went bleh there for a minute. Sorry. I'm telling you, because I worked it here just a little bit ago. The other day. Okay. So then, she used 1/6 of it for a dresser.
1/6 of 12 or 1/6 of 6?
1/6 of 16.
Okay. Oh. Okay.
Wait, what did I do?
First I did
Okay, so when I did this, because I did 6/8 of 16, 1/6 of 16, hold on, messed myself up. I'm telling you, I did this late the other night. Okay. So then she had 12 left, because she wouldn't have 16 still. And then she did 1/6 of what she had left.
Oh.
12 over 6, which would leave her with how much? 2 quarts. Okay, so this is what she had left over. Oh, Rusty Crusty Dusty cannot do math late at night, apparently. I did something wrong when I was doing it up here on my paper. Okay, so she decides that for her next project, she will need 20 quarts of gray paint. How much more paint will she need to buy? So, if she had this still left over, does she need to buy 20 quarts? She needs to buy, what? 18. Because she still has 2 quarts left. So it'd be 20 minus 2. She would only need to buy 18 quarts. Does that make sense?
Yeah.
Okay.
At first I did it that way, and then I erased it and did 1/6
Right.
of 16.
I know, and see, and I did it the other way. I did it this way first, and I messed myself up. I did it wrong, and I don't even know what I did. And I looked at it, I was like, what did I do? When I looked at it, and I totally messed myself up. The answer is 18, because the question is, how much does she need to buy? How much more paint will she need to buy? And it's 18 quarts. But you have to do all this work to get to that.
Yeah.
But I got kind of derpy when I did my math a minute ago. I'm telling you. When I did it, what, Thursday night? I think that was a get home late night. It was. That was. I'm like, all right. I think we'll get done. Oh my gosh. Which expression represents the phrase 5 times the quotient of 4 and 7? Which one?
I thought
I got B.
B or A. I don't know.
I got B. What is this? Wait, 5 times the quotient.
I think C.
Quotient is divide, right?
I got C.
Really, really, truly
It
C.
is. Oh,
Really, truly C. Now, A is okay, C is better.
Okay.
I would really, truly go with C.
Really?
Now, because B with this is not the quotient of 4 and 7. This is the quotient of 7 and 4. This is not it. This is the quotient of 7 and 4. You don't get the same answer when you divide. That's 7 divided by 4.
Yeah.
This is 4 divided by 7. So now A and C, they're very similar, and I don't think they'll be that close on the EQT. They probably won't be really that close. But get that off of your head. I already had to say get the hood off of your head to someone else, and I really hate having to say it. Let's see. And then you've got, because it has parentheses, and it really truly identifies order of operations.
And there's a pen. There's
Now, number 16, you really have to pay attention with number 16. Now, I really paid attention to what it said. I truly followed the steps. The 4th grade classes at Smithfield School used 6 identical buses to go on a field trip. So that's an important information. All the buses were the same. There are a total of 35 seats on each bus. That's important. All of the seats on 5 buses were filled. So I know that on 5 buses, there were 175 people. The 6th bus had 3/5 of the seats filled. So 35 of the seats on bus 6 had 21 people. 1/4 of all the passengers on the buses were adults. So out of all these passengers, see, I'm taking all of the information and I'm doing it one step at a time instead of trying to read all of it together. One step at a time. You see how I'm reading it, and I'm working it as I'm reading it. So all of my passengers, buses 1, 2, 3, 4, 5, bus 6. All of my passengers. 1/4 of all of my passengers were adults. 1/4 of the passengers. So 196 divided by 4. So 49 for adults. How many adults went on the field trip? Oh, look, 49. Just doing one step at a time.
Wait, when you get
1/4 of all of the passengers. Just following the steps that they gave me. And then number 17 is strictly following the PEMDAS. PEM whatever. So, which expression is equivalent to 46? You would just have to work them. So, if you have 4 times 3 times 3 plus 10. Parentheses first, 9. 4 times 9 plus 10. Then you have to go multiplication, 36 plus 10 equals 46. Well, see, that was A. You got lucky. But I'm going to check B. 4 times 3 times 3 with 3 plus 10. Parentheses first, 13. Then I got 4 times 3 times 3 times 13. Now I go left to right because they're all multiplication.
You added an extra 3.
Did I? Oops.
Yeah.
Sorry.
Oh.
I'm just going to mark it out. Otherwise I'm going to... My bad. So then 4 times 3 is 12 times 13.
It's 100.
156.
Yes.
100%. That's a lot of work.
It's 12 times 12.
Well, you want to make sure that you're right.
Can't keep up.
Well, but you know what? This should have been done this weekend. 4 times 3 times 3 plus 10. All weekend? 4 times 3 is 12. Times 3 plus 10 is 13. Again, 156.
And the next one.
3 plus 10 times 4. Oops. Times 3, parentheses again, 12, times 3. Now, multiplication comes first. So 10 times 12 is 120. So then that's 123. So you were looking for something that equaled 46, and it was A.
Is 143 your final answer?
But the correct for number 17 is A. Is the correct answer.